To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all question number 9 of part B of paper 2 of the G.C.E. O-Level 2021 exam paper. So in the previous chapters I discussed the questions from number 1 to 8 of paper 2. So you all know in paper 2 there are two parts, part A and part B. Part A consists of 4 questions which you have to answer. They are compulsory questions you need to answer on the paper itself. But these, starting from question number 5 to question number 9, there are 5 questions out of which you need to select 3 questions. And here this is the 9th question. If you answer all the parts in this 9th question, it will add up to a total of 20 marks. So you all are familiar with that. Then, if we look at the question number 9a, the following table gives some chemical properties of the metal copper. So, you all are familiar with metals, they have certain properties. So, here chemical properties of the metal copper and 2 other metals X and Y. And it is said that X and Y are not their standard symbols. So, you are familiar with that also, students. You are familiar with the metals, the reactivity, the chemical properties of metals. We have discussed that, and you all know X and Y are not the standard symbols of metals. So then, if you look at the table, the metal is given copper XY, then reaction with water. So we have discussed the reaction of metals with air in the sense oxygen, then reaction of metals with water, that also different temperatures, cold water, hot water, steam. For different metals, it is different ways. Then we have discussed the reaction of metals with acids and also the displacement reactions of metals. So, you are familiar with all those. Here the reaction with water. Copper, there is no reaction. You all know copper is a less reactive metal. Even in the activity series, it comes towards the bottom of the reactivity series. So, the order of the metals in the activity series, you all are familiar with that, students. Potassium, sodium, calcium, magnesium. Then we have aluminium, zinc, iron, tin, lead. Then we have hydrogen. After that it is copper, mercury, silver, platinum and gold. So there copper is towards the bottom of the activity series. And you all know when we go down the activity series, the reactivity decreases. It is the activity series, the metals are arranged in descending order of their reactivity. So, copper is a somewhat less reactive metal, or we call them as moderately reactive metals. So, there is no reaction with water, and if you see reaction with dilute hydrochloric acid, that also there is no reaction. Then, if you look at metal X, reacts fast with cold water. So, we have discussed some of these reactions, the activities. So, you can remember the metal that reacts fast with cold water is sodium. It is actually a vigorous reaction. When you put a piece of sodium into water, it floats in water, it darts around on the surface of water, gives out a hissing sound because of the hydrogen gas liberated, and also it is a very vigorous reaction. So, this has to be sodium. If you look at the next reaction, reaction with dilute hydrochloric acid reacts violently. Even with dilute hydrochloric acid, it is a violent reaction. So, when you see that itself, you can understand X has to be sodium. X has to be sodium. Then if you take Y, no reaction with cold water but reacts with hot water. So, then immediately you know what it has to be, whereas it reacts very fast with dilute hydrochloric acid. Now, out of the metals where we have discussed the reactions, now sodium reacts fast with cold water itself. Magnesium does not react with cold water, but it reacts with hot water and it reacts with steam. But if you take the metals like iron, copper, all those, they do not react with hot water or cold water. So obviously, the second one has to be magnesium. And the first one, that is X, has to be sodium. Whereas here, it reacts very fast with dilute hydrochloric acid. But sodium is a violent reaction with dilute hydrochloric acid. So you can identify the metals using the information given. Then you know sodium comes at the top. Potassium, sodium, the second most reactive element. After that, we have calcium, magnesium. Copper is very less reactive. You all know that information. Based on that, you have to answer the questions. So here, answer the following questions using the above symbols where necessary. So this is something you have to remember, students. Using the above symbols. So copper, the standard symbol is given. So you have to write the answer as copper. Although you have identified X as sodium and Y as magnesium, you don't write their standard symbol. You have to answer the question using the symbols X and Y. Is that clear, students? Because they have said using the above symbol. You have to keep that in mind. So with that, I'll move on to the question. The first part, here also the table is given to you. So we have already identified X and Y. Write the above three metals in the decreasing order of their reactivity. So from the reactions given itself, you can understand the reactivity. If not, we have identified the metals, so you know the order. So obviously you all know sodium is most reactive, so it has to be X. Here the question is decreasing order of reactivity. So the highest reactive metal here is X, then Y, then copper. Or else if you look at the reactions itself, you can see reacts fast with cold water, no reaction with cold water but reacts with hot water. Copper, no reaction with cold or hot water. So from that itself you can understand X, Y, then copper. That is the decreasing order of their reactivity. So you can write it this way: X, Y, copper, or you can write it as X, Y, copper. You can show this greater than symbol, or else you can put a comma and write the order. But they have to be in correct order. X, Y, copper. Is that clear, student? So then the second part, it is required to include hydrogen also in the series you made in one above, according to its reactivity. Here the place between which two metals does hydrogen occupy? The place between which two metals does hydrogen occupy? So already I told you all, but if you recall the activity series. Now if you recall the activity series, you can remember, students, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, then you have hydrogen, then you have copper. I'll write the rest of the elements here so that you can see everything together. You have to write it one below the other, but just for you all to see. So after copper, we have mercury, silver, platinum, and gold. So here you can see the position of hydrogen. Where is it? You can see we have sodium here, then we have magnesium here, then we have copper. Those are the three metals given in the question. Sodium is X, then magnesium is Y, and copper was given. So where do you place hydrogen? It has to be between magnesium and copper. It's less reactive than magnesium, more reactive than copper. That is why you can remember in electrochemical cells, hydrogen is displaced by magnesium. but it is not displaced by copper. Is that clear? So then, if we try to answer the question, here you all know. Here, the place between which two metals does hydrogen occupy? Between which two metals above? So, you don't have to write all three. You have to say it is between Y and copper. So, you have to say Y and copper. So, like I said, you don't use the standard symbols for X and Y. You have to use the given symbol, Y and copper. Is that clear, student? So, this is how you answer this question. You have to use the given symbols, and here you don't have to say all three metals. You just need to say between Y and copper, because Y is magnesium, hydrogen is less reactive than magnesium, more reactive than copper. Is that clear? So, with that, I'll move on to the next part. Again, the table is given to you. Part 3. Of the metals given in the table, state the metal relevant to each of the following statements. So, what are the metals relevant to these statements? A part, stored in paraffin oil or kerosene without bringing into contact with air. What is that? You all know it's sodium. So, that is metal X. Why? Because the reactivity of metal X, that is sodium, is very high. So, you can remember, if you take a piece of sodium, if you cut it, you expose the freshly cut pieces, the surfaces to air within a very short time. They will react with oxygen. So, if sodium is exposed to oxygen, due to its high reactivity, it will quickly react. So, to prevent that, we have to store it in either kerosene or paraffin so that there is no contact of sodium with air. To that extent, it's highly reactive. That is why sodium is not available as metals in nature. They are always present as compounds. They are never present as native metals. You all are familiar with that. So, here the metal is X. You need to write the symbol X, not as sodium. Have to keep that in mind. Then the next one. What is the next one? Extracted by reducing the metal oxide. Now, you all know, students, from the activity series, we can identify the method of extraction. The highly reactive metals, which are at the top, they are usually present in seawater, and also they can be extracted by electrolysis. Using electrolytic methods, they can be extracted. For example, sodium. We have discussed the downcell method of extraction of sodium, that is the industrial extraction of sodium. So, they are extracted by electrolytic methods or electrochemical processes. Then, if you take the moderately reactive metals, they are usually reduced by a reducing agent. For example, we have discussed the extraction of iron from hematite. Hematite is Fe2O3, the oxide of iron. So, the metal oxide is reduced with carbon monoxide. Fe2O3 is reduced by carbon monoxide to extract iron. So, extracted by reducing metal oxides is the moderately reactive metals. So, if we consider iron, zinc, copper, they are all moderately reactive metals. So, they can be extracted using reducing the metal by, so these particular metals that have moderate reactivity can be extracted by reducing the metal oxide. Then the very less reactive metals, which exist as native metals like gold, platinum and all, you need to just separate the impurities from the metal using a simple physical separation technique, say like sifting or picking. So, you are familiar with that as well. If you are to answer this question, extracted by reducing the metal oxide, it is copper. We have discussed the extraction of iron, but copper is also moderately reactive. So, the answer has to be copper. Is that clear, students? You don't write anything that is not given here also. They have said to answer the questions using the given metals. So don't write iron here. Iron is not given. You have to write copper. Is that clear? So with that, I'll move on to the next part. Part 4, the same table is given there. Y is a bivalent metal. So we already identified it. Bivalent. What is bivalent? Bi means 2. Valent is valency. What is valency? The number of electrons present in an element that involves in bonding. So you all know metals lose electrons usually and form a cation. So here bivalent means 2 electrons are there in the valence shell, that is the last shell of the metal, that can be used for bonding or lost during bonding when ionic bonds are formed. Y reacts with dilute hydrochloric acid, giving the metal chloride and a certain gas as products. So you are familiar with the reaction of metals with acids. They form the metal salt with the metal and the negative ion of the acid, and hydrogen gas is released or evolved. That is because it is a single displacement reaction. So like I told you all, the metals that are more reactive than hydrogen, in the activity series, the metals that are above hydrogen react with acids and they displace hydrogen. The more reactive metal displaces the less reactive metal. So hydrogen can be displaced by this particular Y, which is a bivalent metal. Write the balanced chemical equation for this reaction. So here you need to write the metal. Metal is Y. Then we have hydrochloric acid, HCl. Then you get the metal chloride, but the reason they have said bivalent, you know valency 2. Then you know how to write the chemical formula. It has to be YCl2. YCl2. Why? This is valency 2, this is valency 1. When you exchange, it becomes YCl2. And when writing the chemical formula, you write the metal first and non-metal after, or the cation first and then the anion. So Y will be Y2 plus, Cl will be minus. So YCl2 plus H2 gas. Y from hydrochloric acid, when Y displaces hydrogen, it is released as hydrogen gas. That is what they have said, certain gas. So if you are to balance this, Y, but HCl is here. Here there is Cl2 and H2. So you need 2 molecules of HCl. If you put a 2 here in front, then it is balanced. Y plus 2 HCl gives rise to YCl2 plus H2 gas. Here also students, if you all are familiar with the physical state, Y is a solid, HCl is an aqueous, YCl2, the salt is also an aqueous, MgCl2, and hydrogen is a gas. You can show that, but it is not compulsory. Balancing the equation, writing the balanced chemical equation is important. You have to put the value as well, 2 HCl. Is that clear, student? So then you get the full mark for this part of the question. This particular part, if you write this equation completely, you will get the marks. So with that, I'll move on to the next part. This is part 5. A blue-colored aqueous solution of the sulfate of the metal copper was electrolyzed using carbon electrodes. So we will try to understand this electrolysis process. You can remember that, students. You have the electrolytic cell there. When it is an electrolytic cell, you need to have the electrodes. The electrodes are connected to the batteries, the dry cells. So here you have the electrolyte. Now they have said copper with sulfate, copper sulfate. So this is copper sulfate, aqueous, and you all know it is blue in color. And these are graphite electrodes, carbon. This is also carbon graphite. That is carbon. Both are graphite electrodes. You all know carbon graphite. Graphite is an inert electrode. Graphite is inert. it does not react with the electrolyte or it does not undergo any change during electrolysis. That is why we use graphite. Platinum also is an inert electrode, but here it is the graphite electrode that is used. So, graphite electrode, and then you all know when this is positive and negative like that, the terminals, the electrode connected to the positive terminal becomes the positive electrode and the electrode connected to the negative terminal becomes the negative electrode. And by convention, the ions present here, the negative ions or the anions migrate towards the positive electrode and the cations or the positive ions migrate towards the negative electrode. So here, what are the ions present? Now you all know copper 2 plus aqueous is there. Then there is SO4 2 minus aqueous. Then you have the H plus aqueous from water and OH minus aqueous also from water. Out of these, if you consider them, copper is less reactive. Then out of the two cations, copper and hydrogen, copper has the tendency to get reduced. So, copper will get reduced. At the same time, if you consider the negative ions, there are many factors that determine which gets oxidized, but here you can remember OH minus ion gets oxidized. So, what are the reactions taking place? Near the negative electrode. So, you can remember students, near the negative electrode, what will happen? Copper ions, Cu2 plus aqueous, takes up 2 electrons and become Cu solid. So, copper deposits at the cathode. Now, this is reduction. That means it is the cathode. The negative electrode is the cathode here. So, copper will deposit at the cathode and you all know it is a reddish brown color substance. Reddish brown substance. Brown deposit or brown color deposit you can say. Then at the same time, if you look at the positive electrode, near the positive electrode, what happens? The OH minus ions migrate towards the positive electrode and they get oxidized. You can remember 4OH minus gives rise to 2H2O liquid plus 1 O2 gas losing 4 electrons. So, this is the oxidation reaction taking place at anode. The positive electrode is the anode, negative electrode is the cathode. So, here you will see liberation of gas bubbles. Liberation of gas bubbles. What else do you see? Now, this is copper sulfate solution. Copper sulfate is blue in color, that was mentioned. When copper ions are being used up, when they undergo reduction and deposit at the cathode, the amount of copper ions in the solution, that is the electrolyte solution, will decrease. Because of that, the blue color of the solution will gradually decrease, and when you continue the electrolysis process for a long time, it will become colorless. So, that is an observation. So, there are 3 observations. You see near the negative electrode, that's the cathode, you will see a brown color deposit, which is copper. Near the positive electrode, that is the anode, you will see the liberation of gas bubbles. And also, you will see the gradual decrease in blue color of the solution and finally, the solution becoming colorless. Those are the observations you can see from this activity. So, you are familiar with this electrolytic process. Is that clear, students? So, now that I have revised this, you can easily answer the question. Here you can see a blue colored aqueous solution of the sulfate of the metal copper was electrolyzed using carbon electrode. So, we understood that. Write the half reaction taking place on the cathode during electrolysis. Half reaction near the cathode is the reduction of copper. So you have to write Cu2 plus aqueous takes up electrons, 2 electrons, you have to balance, that forms copper solid. That is the reduction half reaction. So here, since you know it is copper, we write it as copper itself. So the reduction half reaction taking place on the cathode. Then B part, what kind of a color change occurs in the electrolytic solution during the above electrolysis? So we said blue color decreases gradually and then the solution becomes colorless. It becomes colorless. Blue color decreases gradually and then the solution becomes colorless. So is that clear, student? So then I'll move on to the next part. Fourth part, a simple cell is made using a copper metal plate and a zinc metal plate as electrodes and a dilute sulfuric acid solution as the electrolyte. So here it is a simple cell, means it is an electrochemical cell. So you are familiar with this also. So here we have discussed electrochemical cells. You are familiar with that as well. So here what do? We use 2 electrodes. So this is dilute sulfuric acid. There is H plus ions, sulfate ions from sulfuric acid, H plus ions and OH minus ions from water. And here we are using zinc electrode and copper electrode. So that is what is given in your question. You can see here copper, using a copper metal plate and a zinc metal plate as the electrodes. And in a simple cell, you all know, students, this is connected. Either you can have a ammeter or a galvanometer or even a light bulb, so that to see whether there is current flowing through the cell. Then what happens here? Now out of these two, I already gave you all the activity series. You all know zinc is more reactive than copper. So because of that, zinc will undergo oxidation. So here zinc will undergo oxidation. Zinc solid loses electrons and becomes zinc 2 plus aqueous. So what happens? The zinc ions go into the solution. Electrons remain on zinc. Because of that, zinc becomes negatively charged. At the same time, if you look at this, copper is less reactive. So that does not react, but there are ions in the electrolyte solution. Out of these ions, you can remember, now if we take H plus, OH minus and sulfate, H plus migrates towards copper. If you write the balance equation, 2H plus aqueous takes up 2 electrons, forming H2 gas. So this is the reduction. And so this becomes the cathode. And here, since H plus ions are taking up electrons from the copper electrode becomes positively charged. So here the cathode is positively charged copper, whereas the zinc is the negatively charged anode. Anode, that is negatively charged. So at this time, there are more electrons on zinc. Electrons start to flow from zinc to copper, because copper, there is a reduction in electrons. They are being taken up by H plus. So electrons flow from zinc to copper, and by convention, current flows from copper to zinc. Is that clear, student? So that is how the electrochemical cell functions. So now if we answer the questions based on this, which metal acts as the anode of the simple cell? Which metal? Zinc. We have understood that oxidation occurs at zinc. That is the convention. So here zinc undergoes oxidation. Zinc metal dissolves. You see the liberation of gas bubbles near copper. Then B part. In which type of ion does the concentration remain constant in the solution of the electrolyte when the simple cell operates? Now here there were three different ions. You can remember, students, I told you all there are three different ions. H plus ions are being used up, whereas you have sulfate ions and OH minus ions. So what are the ions that remain constant? Now sulfate, you know, in any of these processes, they do not react. So the sulfate ion always remains constant. In copper sulfate, sulfate remains the same. Here also H2SO4 sulfate remains the same. So the answer for this question, in which type of ion does the concentration remain constant in the solution of electrolyte when the simple cell operates? You have to write the answer as sulfate. So here you can either write the formula SO4 minus, or you can write it as sulfate ion. Sulfate ions. So that is sulfate ions. You can either write the chemical formula of the ion SO4 minus. You all know it's a molecular ion or a radical, or you can write the name. Is that clear, student? So with that, I'll move on to the next part. Now this is part B. So there it was a chemistry related question where we looked at both electrolysis as well as the simple cell electrochemical process. Now this is part B. There you can see equipment A converts the sound waves sent out by a speaker addressing a public meeting to an electric signal of low amplitude. So here you all can understand it is a physics related question. Now, if we look at the question in more detail, equipment B. So, here you can see the diagram. A speaker is speaking to the equipment A that converts the sound waves sent by a speaker addressing a public meeting to an electric signal of low amplitude. So, you all know what does that. So, it is an equipment that functions based on electromagnetic induction. It is the moving coil microphone. So there the moving coil microphone converts the sound energy to electrical signal. Then what happens? You can see equipment B converts the electrical signal of low amplitude to an electrical signal of high amplitude. So there is amplification of sound taking place. So A has to be a microphone. Then there B amplitude increases. So this is amplification. Or we can say amplifying process. Amplifying process. You all know transistors act as sound amplifiers and signal amplifiers as well. So here amplifying process takes place. Then equipment C converts the electrical signal of high amplitude to sound waves again. So there the signal of high amplitude is converted back to sound waves. So there you all know it has to be the loudspeaker. You give a varying current and that converts it to sound waves. You all are familiar with that as well. So here it has to be a loudspeaker. So this is a public speaking system. Microphone functions based on electromagnetic induction. Then amplifying circuit, you have a transistor that acts as the amplifier, sound amplifier. Then you have the loudspeaker that converts the amplified electric signal to sound. So that is the process taking place here. Then the first one, name the equipments A, B and C. So I have already written it, but if we rewrite it again, A is microphone. So then B. Now B here, students, I said it is the amplifying process. Now if you look at it, initially the microphone has converted the sound waves to signals, electrical signals. Then what is being amplified? It is the electrical signal that is going to be amplified, but they are from low amplitude to high amplitude. So the signal is converted. Then what type of amplifier is that? It has to be a signal amplifier. So here it has to be signal amplifier. Signal amplifier. Then C, as we identified, is the loudspeaker. It is the loudspeaker. So A is the microphone, B is the signal amplifier, and C is the loudspeaker. So with that, I'll move on to the next part. The second one, explain briefly the process taking place in equipment A. Now, equipment A is the microphone. You are familiar with the structure of the microphone, students. There is the diaphragm. Then inside you have the magnet and there is a coil around it. So what happens when the sound waves are given to the diaphragm? The diaphragm vibrates. Due to the vibration of the diaphragm, the coil that is connected also starts to vibrate. Now the coil is around the magnets. So there is a magnetic flux. Due to that magnetic flux, there is an induced electromotive force which gives rise to a varying current signal. So that is how the sound waves are converted to electrical signals, or sound energy is converted to electrical energy in the microphone. That is what you need to explain here. So here we can say the diaphragm vibrates according to the sound waves. Then the coil vibrates, causing a magnetic flux. This induces an electromotive force that results in a varying current. So in this answer, the important things, you have to say the diaphragm vibrates according to the sound wave, and because of that, an electromotive force is induced and it causes a flow of current. So is that okay, student? So if you write that answer, it is correct. So with that, I'll move on to the next part of the question. Now here you can see the third one. Draw the structure and their circuit symbol of the transistor, the main electronic device in equipment B, and name its terminal. So you have to draw the structure and the circuit symbol of the transistor that is present in equipment B and name its terminals. So when you say transistor, students, you all know there are two PN junctions. So because of that, there are two types of transistors, the PNP transistor and the NPN transistor. So each transistor has three terminals, the base, emitter and collector. The emitter emits the charge carriers, collector collects the charge carriers, and base acts as the control of flow of charge carriers. So you can remember that. So you have to draw the structure and the circuit symbol. If we do that, so structure, it is going to be like that with the 3 terminals. So here if we take the NPN transistor, both the N terminals act as the emitter and collector, and this will be the base. So here the emitter is N, so electrons are going to be the charge carriers. Charge carriers flow from N to emitter, base to collector, but the current flows from positive to negative. So current flows from collector to emitter through the base. Accordingly, you can draw the circuit symbol. So if you are to draw the circuit symbol, you all know students, we draw a circle like that, then a line with this line that indicates the base. Then you have these 2 terminals. So here this is the base. The middle one is the base. Then how do you identify the emitter? Emitter is identified by the direction of the arrowhead. So if I take this as the emitter, you can do it either way. If I take this as a emitter, here like I told you all, the current flows from collector to emitter. So from base towards the emitter. Then how do we put the arrowhead? It has to be in this direction. And this will be the collector. So this is the diagram. This is the symbol, circuit symbol of NPN transistor. So here we have to label it as NPN transistor. So normally in our activities, you all know students, we use the NPN transistor. So this is the NPN transistor. But here draw the structure and the circuit symbol of the transistor, the main electronic device in equipment B, and name its terminal. So but since there are 2 types of transistors, you need to draw the other one as well. So there, if we draw the structure, it is going to be like that. So here again emitter, but this is going to be PNP, collector and base. You can write the letters also E, B and C, that is also okay. But here you all know, since it is PNP, emitter emits holes. So what is the direction of the current flow? Current flow will be from P to P. That means emitter base to collector. The charges also flow from emitter base to collector. Current also flows from emitter base to collector. So how do you show the symbol? Symbol is going to be like that. So here this is going to be the base, collector, emitter. Then what is the direction of the current flow? It is from emitter to base. We always identify the emitter from the arrowhead, and the direction of the arrowhead indicates the direction of the current flow. So instead of memorizing, students, if you remember, if you understand this, then you can draw the circuit symbol correctly. So you know P, charge carriers are holes. So holes are the ones that are going to flow. They are positively charged. So when positive charges flow from emitter to collector, current also flows from emitter to collector. In the previous one, NPN transistor, charge carriers are electrons, which are negative. So negative charges flow from emitter to collector. Therefore, current flows from collector to emitter. So this is the PNP transistor. PNP transistor. So that is what you need to draw here. Is that clear, student? So with that, I'll move on to the next part of the question. So here, fourth one. Name two main parts in the equipment C. Equipment C, we identified it as the loudspeaker. In the loudspeaker, what are the two main parts? You have the cardboard cone that vibrates. When that vibrates only, the sound energy is produced. At the same time, inside we have a magnet and also a coil. So those are the main parts of a loudspeaker. So you can say there is the cardboard cone, or you can write the magnet, or you can write the coil. So they have asked two main parts. You can write any two of those. So when there is the signal, when current is flowing through the coil only, that is placed in the magnetic field, there is a force generated. That makes the cardboard cone to vibrate. That in turn will produce the louder sound wave. So all three parts are the main parts: cardboard cone, magnet and coil. You can write any two of them. So with that, I'll move on to the next part, part 5. In which characteristic of sound do the sound waves sent out by the speaker's mouth and the sound waves emitted by the equipment C differ from each other? Speaker speaks with less loudness. That's why the sound cannot be heard by all the audience. So when it is sent through this system and from the loudspeaker, you get a louder sound so that the audience can hear it clearly. So the loudness of the sound is increased. That is what you need to write. The characteristic of sound is loudness. That is the purpose of having these, no student? Increase the loudness of sound. So with that, we will move on to the next part of the question. Part 6. When another speaker addresses the meeting in place of the first speaker, what characteristic of sound is different in the sound sent out by him? Now you all know when we discuss the characteristic of sound, like we said, the loudness is one characteristic which depends on the amplitude as well as the energy of the sound wave. So in the process, you saw that the sound wave, the signal is amplified. That means the amplitude of the wave is amplified. Therefore, the loudness increases. Then there is the pitch of the sound. Now, the pitch depends on the frequency of the sound wave. That you all know. So, that is pitch. Then the other character, the third character, is the quality of sound. So, this quality is determined by the source of the sound. Like say if you have two musical instruments, the piano and the guitar. The same note C produced by the piano is different from the note C played by the guitar. So, that is due to the characteristic of the sound, quality of the sound. So, this quality depends on the shape of the sound wave. Same thing goes for the two speakers. You can differentiate their voices because of the quality of sound. So, this particular quality depends on the shape of the sound wave. So, here the question is, when another speaker addresses the meeting in place of the first speaker, what characteristic of sound is different in the sound sent out by him? It is the quality of sound. Quality of sound. So, that is the answer. With that, students, I have completed this question number 9. And as you know, this is also out of 20 marks. So, with that, I have completed the paper 2 of the G.C.E O-level examination, for that matter, the full paper. Initially, I started with the MCQ, that is paper 1. After completing that, I discussed the part A of paper 2, then part B of the paper 2. And here also, I have completed all 9 questions. So, I am sure with this, you all have a very good understanding of the way of answering the questions, and as well as you know the answers to all these questions.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.